Did you know that humans discern almost 80% of all information about our surroundings from sight alone? Despite being the most used sense for a majority of people, not many are aware of the actual process behind our sight. So let's take a closer look at how our eyes work. As with any machine, you first need an input in order to start the process, like trains using coal or cars using gas. The eyes also require an outside starting component. For the process of sight, our component is light.
According to the National Eye Institute in 2022, light first passes through the cornea, a clear dome structure at the front of the eye that protects the rest of the eye from possible infections. Because of the cornea's rounded shape, as light passes through, it is bent in a singular direction. The light bent by the cornea enters into the rest of the eye via the pupil, which is a small opening at the center of the eye. The iris, which is the colored area surrounding the pupil, can shrink and grow, much like the shutter of a video camera when it is zooming in or out of a shot. This helps to control how much light is let into the pupil. Once light is through the pupil, it is then filtered through the lens, which is a clear inner structure of the eye. The lens and the cornea both work in harmony in order to focus light onto the retina.
The retina, which is an extremely light-sensitive tissue on the back of the eye, is made up of cells called photoreceptors. According to Dr. Trevor Lamb's 2015 article, photoreceptors are specialized neurons made up of two unique and specific shapes called cones and rods. On their outer segment, the side which faces the inside of the eye, there are discs which absorb and process the light. On their inner segment, the side that is embedded into the eye structure, both cones and rods have synaptic endings which help them connect to other neurons. However similar, cones and rods differ in two very distinct ways: their shape and their function. Rods are much more long, thin, and rectangular shaped, more like a paddle, while cones are slightly shorter, more circular, and shaped almost like a hairbrush. Rods are also specifically used in order to see in lower light environments, like at night, which we call our scotopic vision. Cones are used to see in higher light environments, like out in daylight, which is called our photopic vision. Cones are also the photoreceptor responsible for detecting the differences between colors, while rods are responsible for detecting the differences between shapes of black and white.
Once this information is processed through the photoreceptors, it is then passed along the surface of the retina as an impulse. This impulse reaches a point where the optic nerve attaches to the back of the eye. The optic nerve then carries this impulse and passes it to the brain. The brain processes the information sent as it is carried to the visual center synapses, located at the back of your brain in the primary visual cortex and the visual association area, where it is then translated into images. From light entering your eye to the visual cortex producing an image, here we have how our eyes work behind the scenes to allow for the phenomenon that is vision. Thank you for looking at how eyes work with us.